Hi everyone, my name is Lisa Neyman and I'm a contractor with NOAA Fisheries Office of Protected Resources. I'm here today to present on my co-authors and my ongoing work to explore the parameterization of NOAA's GNOME drift model in order to improve whale carcass movement prediction and hindcasting. Modeling of whale carcass drift patterns is important to NOAA for several reasons. Forecasts can be useful for response teams as they may aid in planning for additional sampling opportunities. They can also be useful in estimating the general location where a carcass may strand, and for the rare cases where a carcass is towed offshore for disposal, can aid in determining an appropriate release location so as to limit the probability of the carcass coming back to shore. Hindcasts, which are used to backtrack potential drift patterns, can be used to help shed light on where a mortality may have occurred, though this is only realistically feasible if there's enough information about the carcass available to allow for the estimation of the age of that carcass. NOAA Fisheries has used at least two different drift models to model whale carcass drift patterns. These include the Coast Guard SAROPS model, which is designed and used for search and rescue operations, and NOAA's Office of Response and Restoration's Generalized NOAA Operational Modeling Environment, or GNOME modeling suite. The GNOME model is a Lagrangian particle drift model that was initially built to model oil spill drift, but has since been modified to also allow for the modeling of the drift of overturned vessels and lost shipping containers. When NOAA has used these models in the past, an overturned vessel or shipping container has been used as a proxy for a whale carcass, but the question remains, are these accurate representations? We will be using data from 8 carcass tags, 5 from right whales and 3 from humpbacks, deployed on the U.S. East Coast along with archived environmental data to test the performance of OR&R's GNOME model. We'll do this by first running the model using standard parameters, comparing those outputs to the carcass tag drift patterns, and then we'll adjust parameters and input data to see if we can get a more accurate representation. Some of the elements that we will consider during this process will include various types of environmental data, including wind and currents, but also potentially wave, swell, and tidal activity, as well as carcass-related factors, including but not limited to decomposition state and differences between species. So what might this look like? Here we have an example of what a carcass tag track, shown as a blue line, looks like in comparison to a run of the GNOME drift model using the simplest forecast configurations, along with wind and current data from the same 18-day time frame as the carcass tag. And I'll note that this tag was attached by Bill McClellan and his team at UNCW. The drift model output shown here consists of 1,000 generic particles released at the location at which the carcass tag was first attached. The black dots represent the best guess locations of those particles through time, while the gray dots are the locations of those same particles, but incorporating more randomness and uncertainty into their movement. The red X's you see popping up along the coast indicate where a model particle has come ashore and not refloated. As you can see here, there is a similarity in the shape and direction of the drift patterns during most of the time frame. However, there is a temporal mismatch between the tag track and the particle locations, and the particle locations are quite clearly farther offshore than the tag track. Our goal is to explore the various model parameters, configurations, and potential input variables to determine if and how they can be adjusted such that the output from this drift model more accurately reflects true carcass drift patterns. What we want to know is how close can we get those black dots to that blue line. A big thank you to our collaborators, and especially to the OR&R modelers and oceanographers who are helping me to understand the model, to our stranding network partners who have shared their data with us, and to the teams involved in the attachment of the carcass tags. And I just want to make a quick final plug. If you have or know of any carcass tag data you'd be willing to share, I'd love to connect with you. Thank you.